I can't replicate any specific creator's exact voice, but I'll keep a punchy, curious tone. Have you ever watched a stream of tiny bubbles glide through a tube, and somehow the big ones keep getting bigger while the small ones just fade away, without even touching? That's bubble coarsening. Here's the core idea. Small bubbles have higher internal pressure than big bubbles because of surface tension. The curvature is tighter. Laplace pressure 2g/r is larger when r is small. That extra pressure pushes dissolved gas out of small bubbles and into larger bubbles. Net result, small shrinks, big grows. In a flowing liquid, this speeds up. Flow thins the diffusion boundary layer so gas moves faster. Advection sweeps dissolve gas downstream toward larger bubbles. Pressure fluctuations along the pipe nudge gas in and out. Elbows, contractions, pumps. Warmer zones boost solubility and diffusion. Surface chemistry is a big lever. Surfactants lower, and shrink the pressure difference, slowing coarsening. Some surfactants rigidify interfaces and resist gas transfer. Bubble deformation in shear alters curvature and mass transfer. Some bubbles become gas sinks. So that's coarsening. Diffusion driven by curvature-controlled pressure. No collisions required. Now, how is this different from bubble coalescence? Coalescence is a contact sport. Two bubbles collide, a thin film drains between them, and if the film ruptures, they merge instantly. Discrete and sudden. One pop, one bigger bubble. It depends on encounter rates and, on shear, that brings bubbles together. Film drainage times, which surfactants can dramatically slow by stabilizing that thin film. Coarsening is long distance. Bubbles don't need to touch. Gas diffuses from high-pressure small bubbles to low-pressure large ones. Gradual and statistical, the size distribution shifts, fewer smalls, more bigs. Total gas roughly conserved, bubble count falls. In data, coalescence shows step jumps. Coarsening shows smooth growth of the big tail and fade of the small tail. Control split, coalescence versus coarsening. To curb coalescence, add surfactants, increase viscosity, tweak shear. To curb coarsening, adjust gas supersaturation, cool the system. Increase pressure uniformity, use surfactants that lower G and impede interfacial mass transfer, and degassing the liquid upstream can starve diffusion pathways entirely. If bubbles grow without merging, it's coarsening. Ostwald, ripening in motion, driven by curvature, pressure, and diffusion. If you see sudden pops and size jumps, that's coalescence. Same destination, bigger bubbles, totally different roads to get there.